Well, hi guys and girls, Emma again. Welcome back to the spare room. And welcome back to another episode of this Patreon build. I had intended to make safety valves today, and I've sort of got a video half shot on making safety valves. And it's an interesting subject, and it's machine work, and it's going to be a few different variations on a theme, I guess. It's a bit scary making boiler fittings like that stop explosions, but they're pretty straightforward, and it's a very, very rewarding job. But it's not going to happen today. It was still waiting for some parts. So, looking in this book, page 76. Engine parts, pretty exciting. We've got a little pulley which goes on the driving wheel side. We've got a crankshaft which is just a bit of 3/16 4mm silver steel. We've got a distance piece which spaces the engine up off the boiler, and looks something like this. This is a pretty straightforward little piece. The only requirement for it really is that it needs to be thicker than the nuts that hold this together. So I've gone ahead and put two little 3mm bolts on there, or I think they're 3, they could be 8, something like that. Bolts about that size, 3mm bolts. And nuts, and measured across the corners of the nuts, and these holes have to clear at them. So that sits on there, and that gives a bit of clearance on the nuts and a bit of clearance on this piece of tin that sticks over the top here. So that gives me a really nice solid strong surface to mount to, and that's what that is about. That's a very simple little job. It's got two holes in it. It's 60mm by 12mm and a bit thicker than the nuts. So we've done that. Next job is the engine frame. That's the other piece on this page. Not that complicated. You mark it out and drill all the holes. These two holes have got to line up on these two bolts. That's pretty straightforward. These two here need to line up for the crankshaft to go through, and this one here is the pivot pin for the engine, the oscillating engine. When everything's bolted together, we'll spot drill through that and put the two little screws in to locate the engine plate. But that's pretty straightforward marking out. I'm going to do that now. It's 68 by 104 with a radius on there and a radius on there. We'll use the radius gauges to mark these. Basically mark the rest out with the rule and rough him out with a hacksaw and file him up. Let's get in and do that. Now I've got a nice sheet of brass here. It's 1.6 brass. It's a bit flash actually. That's what I'm going to use. I have got some 1.6 steel, which would probably do just as well. This will probably, if we've got an engine that we're probably not going to paint or decorate too much, this will do nicely. So first thing to do, mark anything out, is check one corner and make sure it's square. I know my supplier takes a little bit of care with this, but even still, it's out. That corner's pretty good, so we might well use this corner here. So we can run a circle round here and mark that with a pair of dividers, and the same off this corner here, and we mark this one with a radius gauge, and the only hole left is this other hole here for the centre of the crankshaft, and it's 62mm up from the end there, so that's an easy job too. And carefully set up a nice sharp pair of dividers. And that's sort of the shape that we need to be. So that's all marked out. It's got to be bent through here. This line's not even close to right. It's got to be bent through here. This one's got to be modified slightly, so we're going to fix that. Good idea to check your work before you do things. That's more the shape. Up to there rather than that line, so we're going to cut him out to that line. This is quite thick and I don't think I'll cut them with tin snips. A bench shear would be really nice for this sort of work. I haven't got one yet. It won't take long with a hacksaw. It feels like there's a bit of work involved, but really if we get in and cut round there and cut along there, or cut him across there and cut the piece out, it won't take very long. I find this is the easiest way to cut out pieces of sheet. I've just clamped this to, I've got a piece of wood screwed to the back side of the bench here, underneath here, which is really pretty helpful. My little vice clamps on there, and probably a woodwork vice, which will be a very useful thing, will clamp on there too at some point in the future. But I've just put a clamp on there and set it up against this edge here because the floor of the bench or something's moved at some point during the last little while, and this is no longer level. But that's quite useful because you can set that up against there and that's not going to move. So we can just get a hacksaw So this has taken me probably 20 minutes with a file just to clean this up, all down to the line, right around there. Put a radius on there, leave that one nice and square. I've had a bit of a look and I've got a piece of 4mm silver steel. That's because that's what I've got. 3/16 or 532 would do. This is 01 I would say, or probably is W1. It's a bit rusty, but it'll clean up and it'll do the job nice with a bit of a polish. This hole and this hole need to be a good running fit on that. Excellent theory, but if we do this and then bend them, or ream them and then bend them, you're going to find that, I think you're going to find that these holes are going to have a little bit of run out and a little bit of distortion, and this won't go through nicely. So the secret will be to clean these up to about 3.8, something like that. Drill these ones to 3.8, something like that, so that this doesn't quite go through, and then when we cut this piece and clean it up, we can run a reamer through it. And I think I have 4mm silver steel because I have a 4mm reamer, but all these things have got to come together, and it's a good idea to just have a bit of a look through your cup and see what you got before you start a job like this. So I'm going to drill these about 3.8, and these ones here about 3.2, because I think my holes are somewhere close enough, but a little bit of clearance won't hurt. They've got nuts on them anyway. And this one up here is 1/8 or 3. It was 1/8 for the pivot pin in the cylinder. But I'm going to drill that about 2.9, 3mm, something like that, and then we'll run a reamer through that later too. So let's drill these holes, have a look at bending them, and then this needs a good polish up, and we'll try it on the engine. So there we go. There's the 2 holes there for the mounting screws, and 2 holes here for the crankshaft, which have got to be bent at 90 degrees, and another hole here for the pivot on the engine. There's another plate goes on here with 2 screws. So it's quite a substantial arrangement to support the cylinder out here on the end, but this has got a fillet in here just for support. If we bring the engine over here and we put our distance piece on there, 2 screws are going to bolt down on that, and that's going to be nice and solid and steady. So next job is to bend this and clean these holes out so our crankshaft will go through, and to peel the plastic off him and give him a good polish up and bolt it up in place. This is quite solid, and there's a few ways you could bend it. You could put it in the vise and heat it up and tap it round. You could just use a block of wood in a nice big substantial vise and bend it over. You could use a press brake. You could clamp it between 2 pieces on the side of the bench, or between 2 quite solid pieces of steel, and put a pair of vice grips on it and bend it up and then tap it round. Use what you've got there. It's I'm probably going to just bend it in the brake, which will be the easiest and quickest way to get it accurate and nice and straight. So this is what we've got. This looks pretty tidy. It's very easy to get it bent at more than 90 degrees there. And it's very easy to get a twist in it, which I think we may have. If we check that here like this, we're a little bit further than 90 degrees here. You can see a gap under there, and if you have a look, there's a gap under there. So this needs straightening out a bit. Not such a big deal really, it seems, you would think, but it is a bit of a challenge to get it right. Just take a little bit of time with it, and you've got a fairly nice looking piece. This of course won't go through it yet, and it won't go through with a burr on the end. So best thing to do with the crankshaft is cut it to length, take the burrs off the end, put it in the lathe and file a little bit of a taper on it as per the drawing, and give it a polish up. And then we'll have the finished part that we want to run through these holes. I'm going to take some time and do that now. A very simple job, just to cut this off with a hacksaw at the right length, and put it in the lathe on each end and file it up. This needs a little bit of a taper, about 5mm long. I'd probably go as far as to mark that and just take a little bit of a skim off there till it's about 2 degrees. You can set something up and machine it, but to be honest, getting it on centre and getting it nice is going to be a lot more difficult than a file. So that's what I did with the other one, was just filed him up, and that's going to be plenty good enough. I might get in and do that now. I'm lucky enough to have a 4mm collet, which is another good reason to choose an metric size for this particular job for me. And because of that, I'm probably just going to machine the ends of this. At some point when I get... Now we can set this round. If you're confident this is running true, I could set this round very easily to 2 degrees and put a little 5mm taper on there. But to file this up, because this is already running reasonably true, your file's going to follow the contour. So, to be perfectly honest, filing that's going to be heaps good enough. There's a little bit of surface rust on here, so some steel wool or a Scotch-Brite be plenty enough to take that down nice and shiny, and reverse him and do the other end. And there we have the crankshaft. Still too tight to go through these holes. I'm going to run a reamer right through these and get that running nicely. So when we're done, this should run through here pretty nicely. Last job really is to get something that's abrasive. Piece of wet and dry. Sit down and get all the grain going one way and getting it looking nice, and get all your marking outlines right. That'll take a bit of time. I'm not going to do that yet because it still needs a couple more holes in it. It will get a bit of a polish up. But we can find a couple of nuts and we can bolt this in place. Keith Appleton would use a Barco spanner. So that's what we've got. We can check to make sure that's nice and square with the boiler. A bit of a look at that. And that's the engine frame on, so that's another part that was pretty quick and easy to make. Not a lot of work in it. Most of these parts are designed so that a school kid could get them done in sort of a class window. We've even got a start on the engine. We've got a crankshaft ready to go. When I get back, we're going to get this boiler tested and some safety valves made. This is the one I made for the other one, and that's not a bad valve. It's from a little locomotive called Titch that was designed in the 1950s, 1960s. That's a pretty good little boiler valve, and that's what I'm going to do again, I think. And as far as the engine goes, next part's really to make the crankshaft and the pulley, and to work out a spring belt for this end, and to make the plate, the cylinder and the piston, put the pipework in, and we've just about got a finished engine. This will still need a canopy on it, which pivots off the back here and folds down and sits on the chimney ring here. That's a bit of a job. There's a bit of work in that, but it's what's going to make a nice looking engine out of it, so we'll do that as well. But there we go. Thanks for watching. Don't forget to like and subscribe if you're watching this on YouTube. If you're watching it on Patreon, it's probably about the weekend of the summer bash, so keep an eye out for the live stream, and keep out for the winner of the tool making competition. Have a look at those entries coming in. But thanks heaps for all your support, and more soon, guys and girls.